connectivity with the sensors, right from the basics to the sensor with so many sensors here. For this presentation here, I would like to address these topics: the IoT background, little bit theory, and IoT taxonomy, how it is basically working. And the 90% of this session is going to be a practical part, which is in the environment TinkerCAD, which is we are going to do some 3D simulations in that environment for IoT activities. All might have heard about it, Internet of Things, which is nothing but connecting our everyday things, which is electronic things installed with some softwares and embedded with sensors in our day-to-day activities, that has been connected with the internet for the purpose of collecting an information from the environment, and that started exchanging the informations between one another. So that is what we call it as an Internet of Things. There are plenty of definitions available in the internet. This could be very easy for us to understand what is the use of Internet of Things. Actually, the internet era.
Sir Venkat, sir, sorry for the interruption.
Yes, sir. Is it audible?
Yeah, little bit louder, sir. Actually, little
okay.
bit louder. Okay.
Now
Thank
it is
you,
clear. Now it is clear, sir.
Yeah, this is okay, sir.
Okay.
Yeah, this is okay now.
Yes, sir. Thank you. Actually, that internet era is over. Actually, we are living in an environment called smart era. The smart is nothing but not only the internet, that we have to make that things to be think like a human. That is what we call it as a smart. So here I have given some simple examples which we are actually already being in that smart home and smart vehicles. If you look at the smart home, we are having smart TVs, smart mobile phones in all our hands right now, and all our devices in the smart homes is being connected with the internet, so we can control it, we can manage it from anywhere at any time. So when we call it as smart, it's not because of internet. When there is a thing that has to think like a human, when these two are incorporated, then we call it as a smart. The thing is not just because of connecting with internet, we call it as a smart. So when we call it as a smart, then that thing is going to provide some valuable services to the end user. Okay, so if there is a things with some softwares embedded with some sensors, but it has to think like a human, that has to be incorporated with that things, and without any human interactions in that, that has to do the basic things, which is providing the valuable services to the end users. Then only we can call it as a smart thing. It has to support two things. One is intelligent, and it is going to be a preemptive rather than reactive, because it don't have any instructions from the user side. It has to be more robust in nature to provide the services. So based on that valuable services, we called it as an Internet of Things. So here I have just represented in different form for the definition of Internet of Things. I have just splitted that Internet of Things into two factors. One is internet and the things. Internet, which is we actually being in it right from to 2002 till now, almost 2 decades we are living in that internet field, internet era. Right now we move to that Internet of Things. After even next 5 years to 10 years, we are actually with the support of 5G, the Internet of Things limitation is going to be extend like anything. So internet, we know that internet is nothing but, yes sir.
Yeah, just a little bit louder, sir. Audio is going
down. Okay.
Yeah,
let me hold it. Okay.
Okay, sir.
So internet, welcome sir. Internet is nothing but interconnecting different networks all over the world, which makes us to provide the support of cloud, where we can access the data, our informations at any time, at anywhere. And things is nothing but which is going to be everything in this world, which is it is where we are actually living in this environment. Everything can be an electronic things with internet access. So we can take that things as an everything in this world, which is being connected with the internet for communications. So what it is going to communicate, it is going to have a data, and that data, how it has been sensed or collected, and where it is going to be transferred. So how it is going to be accessed, there will be a device called a sensor. So sensor is an electronic device which is going to read or observe the environment values, and that value is going to be stored it in the cloud. So how it is going to be stored? By using the controllers here. in the IoT we call it as a controller. Controller is nothing but again an electronic device which is having that capability of controlling the sensors in terms of accessing the information and connecting with the internet for providing the better solutions and services. Actually, why we need IoT? Here I have given with simple pictorial representations. And if you look at this, is main purpose of this IoT is to make us to live and work smarter, and which is providing the devices nowadays with more robust in nature, which is more automatic, and the things will be communicating faster, and these all things will be incorporated in the business models to provide the better solutions. As you look at here, this IoT is the technology which is actually being fit with all kind of devices and all kind of business domains, not only for education, not only for industry, not only for automobile. This is a technology which is being applied for all kind of domains. It is universally applied in different perspective and different uh, in depth. It is going to apply for all kind of sectors, so it is going to fit with any device, anything, and it is going to provide services for anyone, anybody, and for any services. As I told you, it is not only for one particular domain or one particular business. It is going to provide services for all kind of businesses and any business. And the main success of this IoT is to going to fit with all kind of network setup. It is also suitable for wired, and it is also suitable for wireless, and it is going to apply for any places and for any context. If you look at for any kind of businesses and any kind of end users, it will support it. So that is the strength of this IoT, which is providing the unlimited services and tremendous solutions for different kind of problems which we are facing it in our real day activities. The taxonomy, how this actually is going to perform means the bottom layer which we have a sensors which will deploy it in the environment for different purposes like fire, pollution, temperature, light, gas sensor, motion sensor. There are plenty of sensors available in the market which we can fix it in the environment. That is going to be the lower part, and through that sensor will collect the data which we will do local processing, what we call it as fog or edge computing technology. So if you get the data, we have to store it locally, so that we call it as a local storage within the network. And if you go to the network, it will be connected with that outside world, that is an internet. And once once the data is pushing into the internet, that is going to the cloud for accessing it at any time and anywhere, and we need a cloud storage. So this taxonomy actually, which is divided from the bottom level, we call it as a fog computing, and the upper layer which is right from the internet, we call it as a cloud computing. There are many research also going in these two areas, what data we have to be stored in the local part and what data we have to push it into the internet, how these data should be monitored, and how to make this data more secure. Is more research is going on with the help of blockchain also. And this taxonomy is grouped together with simple architecture here, which is in 3 layers. If you look at, if you search for it, you will get plenty of architecture for IoT. There is no physical, there is no like standard architecture for IoT, but we can say these 3 layers are actually suitable for this IoT taxonomy representation. That is nothing but the bottom layer is smart device, where these sensors and all we used to fix it with the applications or appliance, which we call it as applications oriented or device oriented, we can say. And the data will be being transmitted to the gateway here. So here we have a networking devices for like for analysis purpose, local analysis purpose, and we will filter the data here. So some part of data will be putting into the cloud part, some data we will handle it in the local side. So this is that architecture which we fitted with the IoT taxonomy. So this, I just want to give you the overview of what is IoT and how the data is being processed actually. So after this, we will look at with practical part. So practical part actually, I have planned to deliver it right from the scratch to the like small mini project kind of stuffs. Hopefully everybody will be in laptop, because if you do it in parallel way, it will be very easy and interesting session for you all people. If you are not using laptop, please have a laptop with you or any computer with you. Parallelly you can work with me, then it will be easy. It will be a learning session for all of us. Before I start with the practical part, I want to give you some simple circuit overview, because here the audience heard it from different background, like students and also from faculty members also joined here. So I want to address all the peoples here. Some of you might knowing it, some of you might be a fresher here. So to address both of you, I am planning to start it from the scratch. So this is the basic circuit. So here, if you want to form a circuit, it's a closed conductive environment. So here we need a power supply. Let it be a battery. And here we have a device to which we have to make it up high and low, or that means on and off. Here I am taking it as an LED, light emitting diode. So for a power supply, we have a positive and negative for all power supply boards or battery. So the negative will be called it as a cathode, and positive will be called as a anode. We will see in like a 3D design in the TinkerCAD. So to make you to understand, this is what I would like to go with that. So positive, which we should not give directly to the device. So in between that positive, between battery and the device, we need a resistor here. So the resistor which is going to break that power and which will be giving to the device based on that device requirements. So we should not give that full current to directly to the device. So negative to the device negative, and the positive power based on that requirement we have to split up with the help of resistance. This is what the basic circuit we have to be clear with that. Why it is needed also we will see it in the TinkerCAD, because the TinkerCAD is a wonderful environment where we can learn, and we can mind free, we can work with it. Because when you go for a real device, sometime especially for this kind of IoT stuffs, these are very very small devices. It is not easy at the very first time to handle with these tiny devices, because we have to take care of this very much when you handle it. So once you get practice with this environment, you will get very good confident in it. Then you can easily handle with the IoT devices. That is what I am asking the students to do also. Once they are very comfort and we're getting familiar with the connections and all, they can directly go with the real device, until unless they can practice with this TinkerCAD. Hope I am audible.
Okay, sir. Okay, you can continue in the same level.
Okay, sir, fine. You please open up the browser. For theory, I was a little bit speed, because most of you might knowing about what about IoT, but practical, I will reduce the speed of my delivery. Go to the browser. Actually, once you open the browser, can you able to see my screen now?
Yes, sir. It's clear. Yeah, we are seeing that.
Okay, fine, sir. So once you go to the browser, just open the website tinkercad.com. tinkercad.com. So this is going to be an environment where we can practice it. So as per my knowledge, this environment is providing a best work area for the beginners to explore and to learn the basic about IoT. Not only for IoT, inside this there are so many things for the kids also, for 3D dimension designing part also. But for as far as our technical part is concerned, it is playing a very good role. When you are a fresher or a beginner, you can just go and play with this stuffs, which will gives us more information and real-time exposure. So once you go into this website, just use sign in at the right top. You sign in. So it will ask you the login details. So we can sign in by using our Google account, which is our Gmail account. Hope everyone will have your Gmail account. I'm going to log in with my Gmail account. So click with Google. So here I'm choosing my Gmail account. So this is the once you go into it, this is the home page. So left hand side you can see the menus here, 3D design and circuits and code blocks like scratches and all. Here I have done some of the circuits with code blocks, and bottom you can see the projects. Okay, by default you will have create project. So if you click the create project, you can see the project automatically created like a folder here. So if you click that folder, you can have this as a page. You can change the name of this project. Go to the properties. Here you can rename it. Like if you are conducting any classes, or if you want to do this as a practice, you can do, you can rename it, and you can give the description, and you can save it. And here I have one folder I have created for webinar, so I am going to do it from the scratch. So you please parallelly, you please do it. One or two lab exercises, it will be more easy, and you feel very comfort if you are a beginner. So create, you can just create a folder or just click the circuits. You can do anything. It is your option. You can create a project here, or you can use the left hand side circuits, just a circuits. Okay, it is your choice. So here create circuit. So once you click the circuit here, this is your work area actually. The center part is your work area, and right hand side you can see plenty of IoT devices available. And if you want me to slow down, you please unmute your mic and you can ask me. Okay.
Yeah, it's okay, sir. It's okay. The speed is
Okay.
okay. You can
Okay.
continue in the same phase.
Okay. Okay. So thank you very much. So in the right hand side, you can see the devices, so which we can use it for our scenario. The first scenario, as I told you, in the basic circuit, we will do it with the basic circuit design to understand the scenario. So just type battery here. So once you type the battery in the search right top, you can see 9-volt battery. Just click that battery and just click it inside the work area. And once you click it, use your R key in your keyboard to rotate the device. To rotate the device, you can use your, just select the device and use R key to rotate. So I am going to have it like this. And one more battery, just click it on the right hand side and put it inside and use the R key to rotate it. And just remove this search. Okay, now once you remove the first two components are resistor and LED. First I will go with the LED. So just click the LED and put it here. So LED, as I told in the circuit explanation, it is having two legs. One is cathode and another one is anode. Cathode is negative. Cathode means negative and anode means positive. Okay, cathode means negative, anode means positive. So if you look at the battery is also having two pins. One is positive and another one is negative. Negative is nothing but ground. So negative, I am going to click it from the negative and give it to the cathode leg of your LED. And you can change the color. If you look at the circuits, actually the negative always we used to give it in a black color. So once you give the connection to the cathode leg of your LED, just go right side, you can see the color, wire color, change that into black. List have the list is having many colors. You can choose the black color. And for the positive, just click the positive pin of your battery and give it to the anode of your LED. Anode is positive. The positive wire is going to be in red color always. So make this color as red color. Okay. So very simple. Here we have connected negative to cathode and the positive to the anode. But here we didn't use any resistors here. Directly we have given the supply to the LED. And right side top you can see start simulations. So give start simulation. So once you have given start simulation, you can see that LED is on, but that LED blast actually. damaged, right? You can see that. Why? Because if you move the mouse near to that LED, you can see the current through the LED is 915 milliamps, while absolute maximum is 20 milliamps only we needed. So here this 9-volt battery is giving milliamps 915, so that is which is maximum. So that LED is not capable of performing with that milliamp, so it is getting damaged, okay, blast. So what we have to do, stop the simulation. So that is what I told you in the basic circuit, we should not pass that current directly to the devices. So just select that link, which is a positive link, and click delete. So I am just removing that positive link, and in the right hand side you can see the resistor. So just put the resistor. So the role of the resistor is to receive the power, and that will split it and give it to the device, which is going to be an end device, that LED. Based on that requirements, it is going to provide it. So what I am going to do, this positive leg to the resistor's leg, and from the another side I am going to the LED. That's it. So change, if you want, you can change it, the color of the wires, you can change it to red color. So now this is the circuit as per the design, circuit design, which I so that which I saw it before that TinkerCAD in the PPT. So just click the start simulation. So now you can see that LED is on now without any alert message. So this is the basic circuit, positive to resistor, and then to the LED positive, and negative to the direct cathode. This side, what I am going to do, I am going to make use of bulb here. So type bulb at the search option. So in the search option, if you give bulb, you will get light bulb. So just choose it and put it inside the work area. So bulb is also having two legs here, but bulbs, these don't have actually negative and positive. This is having only terminal 1 and terminal 2. So positive, you can give it to any terminal. I am giving it to the terminal 1 and change it into red color. And for negative, just give it to the another leg of your bulb and change it to black color. So here we didn't use a resistor. Just check start simulation here. But bulb requires more voltage, so this won't need resistor. Here you can see the bulb is on without any problem. This is the first exercise to understand the basic circuits. Now we will see with the breadboard, because if you use this kind of scenario, you can connect with only one devices. If you want to connect more LEDs, more devices like sensors and all, we need a breadboard. So we will use the second one with the breadboard. So stop simulation. Here in the left top corner, you can label it. For example, this is LED with a battery. So you can label this lab which we have practiced, and that will be renamed here, and click this logo. It will go take you to the home page. So this is the first one which we have done it, and next one, just go to the create and create circuits. Now we will do the same thing with the breadboard now. So here type battery again. So you will get 9-volt battery, put it inside work area and rotate it. Same like that here, just search for breadboard. You type breadboard, you will get the breadboard small and breadboard mini. Different breadboards are available. Just take the breadboard small and put it inside the work area. And if you look at that breadboard, if you are new to breadboard, actually it is having two parts. One is the outer side and another one is the inner part. Okay, the outer part which will be working like column wise. So if you move your mouse to the corner, there is a plus symbol and minus symbol. So the plus symbol means if you move your mouse to the corner side, this entire column is going to work as a positive, and this is going to act as a negative. But if you move your mouse inside the breadboard inner part, you can see the selection is going to be in the row wise. So that is what labeled there. First row, second row, third row, fourth row, fifth, like that. This small breadboard is having 30 rows. So if you want to plat the devices inside, you have to choose row wise for each characters, each features. And if you want to fix it in the outer part, it is going to act as a column wise. We will see one by one. We will see both the scenario. So I'm going to, for better, I'm going to make this breadboard like this. Okay, like this I will place it, and control scroll if you want to minimize it. Now I'm going to connect 3 LEDs, for example. So remove the search right hand side and choose the LED, and first I am going to fix it inside the breadboard. So as I told before, if you go for inside, each is going to act as a, each link is going to act, each slat is going to act as a row wise. So sixth means that entire sixth row is going to act as a same pin. So each leg should be in different row. If I fix like this leg is in the sixth row, so sixth row entirely it is going to act as a cathode, and this leg anode is in the seventh row, so all the pins in the seventh row is going to act as an anode. And similarly another LED, so like this. So this LED cathode leg is in the 11th row, so all the pins slats in the 11th row is going to act as a cathode, and anode is in the 12th row, so all the pins in the 12th row is going to act as an anode, which is positive. And one more like this. And now the cathode, which is going to be a negative, so from here to the negative at the bottom, which is going to be the negative slat, and make this as black, and from this LED to here this negative, and this is going to be black, and from this LED to this black, this slat, and make it as black. So from all the cathode of LEDs, I am giving it to the negative slat. Okay, so from this negative, which is from your battery, just take and give it to the any pin in the negative at the bottom slat, and make this as black color. So this entire thing is entire slat, this entire pins is going to act as a negative, so you can connect it with any pin number. And for resistor, take it, and you can place it like this actually, because one leg of the resistor should be in the anode row and another leg of the resistor should be in the positive, because that anode is positive. So for splitting the voltage on the basis of LED's requirements, we have to fix the resistor. So resistor, one leg should be in the positive and another leg which is in the same row of the LED's anode, and choose another resistor and place it like this, which is in the same pattern which we did before, and resistor again, and place it like this. Please ensure that anode's leg should be in the positive slat like this, and from this battery you just give any slat of positive and change this into red color. That's it. So this is a simple circuit for giving more devices. So from the battery I have given positive to the positive of breadboard and negative to the negative of breadboard. But inside the breadboard I have connected more LEDs. So all LEDs cathode I have connected with the negative, and for the positive I have used resistor, and that another end of the resistor's leg is going to be in the positive slat. So if I start simulation here, you can see all the 3 LEDs on at the same time. Why? Because the power is given at the same time for all the plus slats here, pin slats. So from there all the LEDs is getting the power. So now you can observe that the LED is not blinker, it is just on. So if you stop the simulation, it will off. So LED here, it is not blinking. It is, we are actually simulating only for on and off. So that is what we can do it with the battery for making this kind of control. When that LED has to on, if the LED has to off, what I have to do, that and all we will do it with the controller part. So hope you understand how to use the breadboard inner part. So I'm just moving this side. You just, if you click outside of your work area and if you move your mouse, that entire scenario will get moved. So I am just moving this to the corner, and again I am in need of battery to demonstrate that another method of using breadboard. I have used the devices in the inner part of the breadboard. So now for the outer part, so another battery, use R key to rotate, and breadboard small, I am going to put it here. Okay, and take LED now. Now I want to place this LED in the outer part. So if I do like this, is it correct? Can I fix the LED in the outer part like this? I can't connect it because because why, we can see here that anode and cathode, which is positive and negative, are in the same slat negative. It should not be like this. So I have to rotate this LED. So choose the LED and R to rotate. Sorry, like this, and make this LED horizontal purpose. So why I have make this LED like this, you can see the leg of this LED is cathode, which is negative in the negative pin slat, and this leg is the anode, which is in the positive pin slat. And same like this, don't do like this also. Some of you might doing like this. This is also not a correct one. Why? Because if you move your mouse to the LED leg, this is cathode actually leg, but this cathode leg is in the positive. Cathode is negative actually. So this should not be like this. And this leg is an anode. Anode is positive actually, but we have inserted it in the negative. So just choose this and rotate and place like this. So this is the correct way of doing it in the outer part. Cathode in negative and anode in positive. And similarly, we can connect it more LEDs like this. So here I am connecting 3 LEDs like this. So simple. We have to be very conscious which leg is in which uh, positive or negative. We have to confirm it. And then negative, just choose any one slat from the negative and give it to the negative of battery and make this as black color. And for the resistor, if you do like this, here we don't need 3 resistors. One resistor is enough. Just put one leg of the resistor in the positive and another leg inside your breadboard. So from that another part, you take it from the same row and give it to the positive of the battery and change it into red color. Here we are using only one resistor because that resistor is giving supply to all these positive pin slats. So once power is from the battery, it will be given to all the pins of this positive. So all the batteries will get the supply. So start simulation. So now you can see that all the LEDs are on now. Fine. So if you want to use that outer part, you can use like this. And if you want to use that inner part, you have to do the connections like this. And go back to the home page. Now we will do with Arduino board. So go to that folder and create circuits here. So now you here in the search you can type Arduino and here you will get Arduino Uno board. Put it inside the work area. So this is going to be a controller which is taking control over the devices like LED, temperature sensor, Like that we will do now with RGB, red green blue LED. So followed by that, here type breadboard, sorry, breadboard, take the breadboard small and have it here, and search RGB, sorry, search RGB. You will get LED RGB, which is a single device, but it will perform three colors, red, green and blue. And just put it inside the breadboard inner part, then only each leg will be in each row. Okay.
Doctor, sorry for
Hello.
interrupting you,
Yes sir, please.
but could I ask you a question, please?
Yes sir.
If it was a car battery, how would it work?
It will be a which battery?
If it was a car battery, how would it work?
Car battery, it is also having a positive and negative, no sir?
So the same.
Same.
Okay,
We have to
thank
look
you.
at the we have to whatever the battery, we have to look at that voltage level from that battery, that is from that source, and to which device or which for example light or any product, if you are going to give that product maximum capacity, what we have to look at. Otherwise no, when we are practicing here, the students will give directly the power connection to that end device, then that end device will get damaged. That is what the maximum problem we are facing with that IoT devices. When we are giving the power supply directly to the end device, the device will get damaged. So for that we have to use the resistors.
Okay, thank you very much.
Yes sir, thank you. So if you look at this RGB, here we have 4 legs. So if you move your mouse, you can see the first is going to be the red, and second is going to be the cathode, and third is going to be for blue color, and the fourth is going to be for green color. This is ditto of real device. That is what the success of this this environment website. This will give you an exposure of real device. So the connections, everything is ditto with the real device. Once we get practice here, we can directly use the real devices, and also we can generate the coding part also. I will let you know in the next coding. Okay. So here RGB, so from the second pin, which is the cathode, we know that cathode is negative, so take from here and give it to the negative and change this into black color. And for red, blue and green, we need resistors, as we have discussed before. So resistor 1, and from the leg of your red and to the another part of your breadboard, and choose resistor again, and for blue, and choose resistor again, and give it for green. So 3 resistors for 3 colors. Ensure that one leg of the resistor should be in the same row of that particular color pin leg, and another leg of the resistor, let it be in another part of your breadboard. So from there we will give the connections, right? So now we will give the connections for these 3 colors. So for the red one, I am going to take it, just click inside the breadboard in the same row, just click any one free pin slot, and just go out and click it to take the bend, and click it again, and just move with this and give it to the pin number 10. Just like click it and turn it and click it in the pin slot. So if you look at this Arduino is having two sides with pin slats. So bottom side you can see, which is with some power pins, ground, voltage, 5 voltage and 3.3 voltage, and input, output and reset. Some pin options are there, and analog pins are here, A0 up to A5, and this side we have digital pins with pulse wave modulation, which is PWM. Here it is a huge concepts which I can address this within this time limit, but up to my maximum level I will deliver it to you. So on the flow I will explain. Okay. And this is for red color. I have given it to the 10th pin, so change this into red color, and go to the blue color. You can take it up in any one pin slot and just click it, click it, click it, and give it to the pin number 9. and change this into blue color. And for the last one, which is going to be the green color, so take it and click it and give it to the pin number 8. So let it be in green color. So 3 pins I have given for the 3 colors. Okay, so for the negative and for the power supply, so here we have given the cathode to the negative slat. So from any slat from here, just take it, move down and give it to the ground pin, which is at the bottom, and change this into black color. So negative to the board negative, which is ground, and for the positive, which is a power supply to the board, so from this positive pin go down and bottom you can see 5 voltage, so give it to the 5 voltage, which is giving 5 voltage power to the board. So that is what in the red color. Clear? Now we have to do program. Actually by default 8, 9, 10 will not do anything. We have to make this 8, 9 and 10 to give power to make this RGB LED to on in red color, in blue color and in green color. So how I can program it? Even if you simply start simulation, it will not run. You can see it will not execute. So we have to program it. So if you click code, in the right top you have a code option. Just click the code. If you click the code, the dialog box will open, and by default it will have blocks. Okay, so right hand side you can see the by default it will have some blocks of coding. Just put it in the trash, it won't need right now. So I'm going to design our own blocks. So for that in the here you can see some options: output, input. 1 minute, it's still running. Okay, we will do. So here just go to the pin number, set pin number, just drag and put it in the right side parallel work area, set pin number. So first I want that red color to on, so set pin number, just drag that pin number. So first red color is connected with the pin number 10. You can see it in this diagram. Red I have given it to the pin number 10. So pin to high means red color will on. So how long it has to on? So go to controls. So inside the control you can see many options here. First option is wait. So wait block, you can put it inside. This is like a scratch. Hope you all knows about scratch, like that only block code blocks coding. So wait for how many seconds? So let it be for 1 second, no issues. And after that go back to output and set pin number, let it be 10 to low. I'm making that red to off. So first red will on and red will off, and then set pin number immediately. This is for blue color. So blue color I connected with pin number 9. So 9 to high, and this I want to make it on for 1 second. So go to controls and put the wait block for 1 second and come back to output and again add set pin number, now 9 to low. So make it on and off, and put immediately set pin number for the last color, which is green, connected in pin number 8. So click it 8 to high and make this to on for 1 second and go back to output and set pin number 8 to low, which is off. So it will be like an iteration loop. First red will on for 1 second and then blue and then green. So in the time interval 1 second. So once you did it, just start the simulation and observe your scenario. So it is getting delay for me. Sometime you may get it very fast based on internet speed. Is it working for you all?
No, we didn't reach that particular state. We are just.
Oh, am I speed?
No,
I'm
no, it's
going.
okay. No, you continue, sir. You continue because the session is
Okay.
recording. No problem
Yeah.
with that.
Okay. 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 So it is getting initialization here based on speed of that it will work actually, but normally it will execute just like that, but now it is getting delay. Next to that I will work with the temperature sensor with one program, how to interact with the program. Then we will wind up. That is up to that only we will have a time.
Okay, sir. Okay, sir.
But this is very simple actually. By doing this you can get the code also very easily. It will generate automatically that IDE, that is Arduino IDE code in C programming. It automatically generated. Why this much time?
Can we refresh the page?
Yes, now it's connected. Now you can see my screen that red, green.
Yeah, it's working now.
Blue.
We are seeing
It's
three
working.
different colors.
Yes, three colors automatically it is iterating. It is a loop actually. It will iterate a number of times. So stop simulation. And as I told you, you can generate the code. You can play with here. If you did any mistake, you can correct it. And if you want to take up the code, just stop your simulation. And here you have a blocks. Just click it. You have three options here: blocks, blocks plus text and text. So if you click blocks plus text, here you will get the coding part. This is the real coding. This will execute with that real device, Arduino board, with the breadboard, with the RGB LED. If you have given the connections, and if you connect that Arduino board with your laptop, then this code just copy and paste it in your Arduino IDE, then execute. It will works fine. So this is that power of this TinkerCAD. We can do mistake, learn, correct it, and then we can go to the real device. Now I will do with the program directly. I'm going for the new one. At least this part you can start up. This could be somewhat interesting with the temperature sensor. So go to the home page, create new circuit. So here I am going to use Arduino. So again here Arduino board and breadboard. I'm in need of breadboard. So breadboard small. So here I can move this Arduino this side and this side. So simple scenario, just type temperature. Once you type temperature in the search, you will get one sensor here, temperature sensor, which is TMP36 sensor. Choose this sensor and put it inside the breadboard. So it is going to have three legs. One is the power leg, and middle one is the voltage output, and the last one is the ground. Very simple. All the sensors will have this kind of setup only. So ground is, we know that it is going to be a negative. So from that ground pin, I am going to give it to the negative and black color. And for the power, I am going to take it and give it to the positive and make it as in red color in the positive slot. Okay. And from the positive, any pin slot, you can take it and give it to the 5 voltage Arduino board and make it as red color. That is going to supply the power for the breadboard. And for the negative, I have to give it to the ground. So take it and give it to the ground of your Arduino board and make it as black color. So the basic positive and negative we have given. The middle one is the voltage output. Now we have to take the coding for this temperature sensor. It is readily available in the internet. Just go to another tab, go to Google and just type TMP36 temperature sensor Arduino code. That's it. TMP36, that is the sensor which right now we are using. This is actually a real device which is also available in the market. Temp36 sensor, temperature sensor for Arduino code. Just Google it, enter. The very first search hit is going to be that you may get a number of search hits with ready-made codes. I'm going to use it with the first search hit, which is bc-robotics.com, and go into that website. So here they explained everything, and if you go down before 8th step, just upload it in the Arduino IDE. They have done it in the real device actually. So this is the coding, just 20 lines coding. I'm just going to copy it, just select it and go back to the environment where we are working actually, and click the code. Now actually we are working with the coding part. So now I am going to change this coding blocks to only text. So once I click only text, it is asking me to continue. Just click continue and Control A, Control V to paste it. Now you can see the sensor pin is connected with A0. A0 means analog pin. So from this sensor, I'm going to take that middle pin, which is V out, and I'm going to give it to the analog A0. Let it be in green color. That is what they have given it in the coding. And here they are reading the value by using sensor input variable analog read, because we are using analog pin A0. So analog read of A0. So that will be readed here, and that is converted into temperature by using the formula here, and that is printed in the serial monitor at the bottom. So this is the serial monitor, like a terminal window for normal programming, CLI mode. Okay, command line interface like that. Here we have a serial monitor. Here we can display the output. So there they are displaying current temperature followed by the temperature. That's it, nothing else. Just start the simulation. So now you can see that this temperature started reading the temperature value, and here it is printing it up. So that right now the temperature is 24.71, and if you click the temperature sensor here, you will get a slider. So you can move the slider and you can see the temperature value is getting changes. So like this, and if you can reduce it and you can increase it. So like that you can increase and decrease the temperature value. I am just stop and clear it. Now I am going to add some features with we have seen RGB LED. So I am going to make it as an alert mechanism. So I am putting RGB here. Okay, so cathode I am going to give it to the negative and give it to black, and I am going to use two resistors, one for red and another one for green. Red for danger and green for normal scenario. So if temperature exceeds above 50°, I want to make this RGB to on red color for alert, and this green color for normal. So for this red, I'm choosing pin from resistor and giving it to the 8th pin. This is for red, and for the green, I'm going to give it to the pin number 9. So this is for green, right? So I'm using green. Now we have to touch the coding. So go to the code. So here we have two outputs. So red, I am declaring the variable red for red color, and red I have inserted with the pin number 8. So equal to 8. And int, I used another one color green. So variable name is green. You can give any variable name. For my understanding, I am giving green color, and that is in 9th pin. So 9th pin. So here I have to initialize it. So pin mode of 8 comma, this is going to act as an output. So 8 comma output, just copy it and paste it, and this is going to be 9 is also, it is going to be the output. Or you can give here as red, the variable name also you can give it green, because red you have initialized to 8, green you have initialized to 9. And followed by that bottom here, I am going to check the condition if temp is greater than, for example, 50°, and inside that I am going to make digital write of red comma high, and digital right of green comma low, which means red color is going to be high when the temperature is above greater than 50, and I am copying it, and else the temperature is normal. So digital right of red is going to be low, and green is going to be high. That's it. I have edited this coding for RGP. I have initialized the value of pin number and declared it as an output. And here, if it is greater than 50, red is going to be high, and if it is less than 50, the green is going to high. Simple. And just start the simulation. And now you can see the temperature is 24. So green color is here, is displaying here. So which means the temperature is safe now. So I click the temperature sensor, and if I increase the temperature, now you can see the temperature when it becomes above 50, it automatically changed red color. Like that, we can do programming for simple scenarios kind of things. And we can also add buzzer, LCD and all. And due to time constraint, I can't proceed further, but I have my YouTube channel, and for your information, if you are interested in this and also real device, hope this page is visible for you. And here I have done some 3D simulations with projects for temperature, everything, and real devices also with Arduino board and Raspberry Pi. I have done an exercise with real device with email, SMS alert and all. And for packet tracer activities, I will give this page in the chat window. If you wish, you can go and check with that. And stop sharing my screen. And 1 minute, I will